She's actually going to only present a very short amount of information, but it's actually very important. It really ties into, it really probably going to tie in tomorrow, today, and yesterday together, as well as anything else. As you can see, the title of the presentation she's going to be giving is looking at the ASD, or autism, and the autonomic nervous system. When we look at a lot of the dysfunctions that we talked about yesterday, when we talked about testing for, a lot of what we're looking at Cyrex, and a lot of what Latish was talking about, almost all of those dysfunctions, neurological, metabolic, detoxification, gut issues, immune imbalance issues, can be explained by an imbalance or a dysfunction in the autonomic nervous system. One of the areas that we're looking to study in the group that we're doing down in Cuba is really looking at the autonomic nervous system as it relates to functional disconnections and functional neurology. And autism is again a great example because it's a very extreme example of what's going on. So we have Talia Estevez, whose father, Dr. Calixto Machado will explain, but he's a brilliant man, and all I can tell you is that we met with him when we were in Cuba, and he was, at one point, and I'll explain to you, one of the top physicists at the Russian equivalent of NASA. And he went into these stories about what Russia was doing in the 80s in brain research, which was wild. I mean, it was like awesome to hear like what they were doing. I mean, we could never get away with any of that stuff in the United States, but it was really cool. Really cool stories. I wanted to spend all day just listening to them in the living room in the rum help. Dr. Machado is going to give a better introduction and explanation, and then we have maybe a 15-minute presentation, and then Dr. Machado is going to come up and speak. So, here's Dr. Machado.
Good afternoon, and my best regards from Cuba, from Havana. I'm very proud to produce the presentation of autonomic spectrum disorders and autonomic system. You will know why we went into this topic when I present my lecture, and she will also explain. What I want to talk about this man who is here is Professor Mario Esteves. I can only say that I met him. He was my mentor when I was running my program, specialty in urology and clinical neurophysiology. And after that, we became brothers. He says that he's my oldest brother, but to me, it's something special in my life. I can assure you that he's one of the most brilliant and the worldwide expert on autonomic system, without any reason. And moreover, I don't know a person who handles biological signals, statistic, computer, whatever he faces. Without any doubt, he's one of the most brilliant researchers in my country, at any place. Today, I also have the pleasure to introduce his daughter, Dr. Talia Estevez, who will present a short communication of his thinkings about the future of autonomic system assessment in autism and in all of disease. Talia will also talk about his father, but I mean, I'm also, probably he says that I am his brother, but I am also his son. Talia, please.
Dear Chairman, fellows of the International Academy of Functional Neurology and Rehabilitation, colleagues, friends, I'm very grateful to Dr. Jerry Eastman, Dr. Robert Merillo, and Professor Machado to add a few words about my father, who was confident that I could present you some of his ideas about this scientific and social problem, the autism spectrum disorder. I ask your permission to give this brief information. My father was born in Cuba in 1942. He graduated as a medical doctor at the then symbol National Faculty of Medicine in Cuba in 1965. In 1972, he became a specialist in Physiology, and in 1973 obtained the scientific degree of Master in Science under the guide of Professor Troy Young, USA, and Talia Harmon, Mexico. For some years, after scientific work in the field of military aviation and medicine. From 1977 to 1980, developed special studies in the Institute of Experimental Medicine of the City of St. Petersburg in Russia, then Leningrad, under the guide of N.T. Becheriva, and obtained a PhD degree in medical sciences. In parallel, since 1978, he began to work in the organization of the scientific works associated with the experiments to be developed in the cosmic flight of the Cuban cosmonaut Arnaldo Tamayo Mendes. From 1982 to 1992, he continued working in the Soviet Special Program Intercosmos and became the head for the coordination of experiments in the field of neurophysiology of the spatial program. In 1991, the equipment and software with code name Cortex-2 developed under his direct control by Cuban and Soviet specialists show his real possibility for the study of some neurophysiological functions of cosmonauts during long-lasting flights. And after that, he received several decorations, as the Yuri Gagarin Order, the Gold Medal of the Academy of Science of Czechoslovakia, the Medal of the Institute of Aviation Medicine of Poland and Germany, and the higher decoration for the scientists in Cuba, the Order Carlos Bota Finland, in the first degree. The International Academy of Astronautics France elected him as a correspondent member in 1991, and 4 years later, 1995, elected him as a full member for life. He obtained his discharge with honor from the Cuban Armed Forces in 1998 after 36 years of active service, and later has maintained his scientific production collaborating with different health institutions in Havana, and especially with Dr. Machado in the last part of the years. As can you see on the first slide, on this presentation we will try to show you some facts, commentaries, and technological approaches related with the study of that frequently forgotten but integral and vital part of our nervous system, the autonomic nervous system, in such sensible, complex, and challenging medical problems, the autism spectrum disorder. A standard query to the PubMed National Library of Medicine database revealed a relatively high number of items using as medical subject heading the compound term autism or autistic as shown in the table. The addition to the basic query of widely used clinical neurophysiologically ancillary tests show very low number of items, from 0.11 to 1.52%. For a problem whose origin everybody must suspect that has a brain source. The autonomic terms, up to the basic query, also show, to say the least, that autonomic complaints are not present in the autism spectrum disorder. The graphic at the bottom of the slide shows that the interesting to us questions submitted to this research represent only 4% of the publications about autism included in the database with the medical subject heading used. Then you could be right to see that our presentation is a futile effort or only a waste of time for all of you. Obviously, this will not be the case, at least so we hope. The group of Professor Machado, with the joint effort of very dear to us members of the IAFNR and other friends recently, has contributed to publish a study using quantitative electroencephalogram, QEEG, and the functions on quadratic coherence oriented to find if they are aware of no connectivity problems in children with ASD compared with the control healthy pair group. Byproducts of this publication can be considered those included in this slide. Here, we are only going to show some of the graphic possibilities of the software. EEG form, mentioned before as one of the byproducts of the joint collaboration. The graphics are obtained from the software toolbox directly. In the upper graphics are included the quantitative EEG spectra in the range from 0.5 230 hertz of a child with autism spectrum disorder, identified with the letter A, and to the right upper part, the corresponding EEG of a control healthy child. The graphics in the lower part of the slide show the spectrograms for the gamma bands of the same ASD and control children.
Hi, I'm going to be reading some of the slides. Thanks to Dr. Estevez for these nice detailed notes. This slide shows the long-range and inter-hemispheric coherence values observed for the subjects. As can be seen from the colors representing the coherence values, high values in almost all of the EEG bands are observed in the autistic child in comparison with those in the healthy control. The upper part shows the individual results for the long-range coherences, while in the lower graphics are represented the interhemispheric corresponding values. It must be emphasized that all the graphics about the selected subjects were obtained from the electroencephalogram of both children in basal resting conditions. As in the before slide, we can find clear differences between the values expressed as colors for the two children. In the upper part of the slide are shown, in the upper part of the slide are shown the results for the short-range interhemispheric coherences, while the lower part shows the values for the transversal interhemispheric coherences. In 2002, a seminal review paper published by Kevin Tracy in Nature changed the way many biologists and doctors thought about the role of autonomic nervous system in mammals and men. The concept of the inflammatory reflex, which includes the products or molecules generating the reflex, the input arm, the intercalated neurons, the integrative centers in the central nervous system, and the output branch were clearly described. In the slide at the left is shown the neural wiring of the cholinergic anti-inflammatory pathway, which balances cytokine production in the organism. Cytokines are activated by pathogens, ischemia, or trauma. The cholinergic framework, responsive to the M1 agonists, inhibit through the efferents of the vagus nerve the production of cytokines. In the autonomic visceral afferent signals in the vagus nerve are the afferent branches of the inflammatory reflex that arrive to the nodose ganglion and posteriorly enter the brain, making synapses with the nucleus tractus solitarius. From there, other fibers reach the cholinergic brain network, so it becomes configured with the inflammatory reflex. Here in the right part of the slide, we can see the neural structure of the vagal immune reflex. Cytokines signal neurons of the afferent vagus nerve. The neural information is relayed to the nucleus tractus solitarius. From there, projections lead to the area of the stroma. This nucleus connects to the hypothalamus, which activates the hypothalamic pituitary adrenal axis. Second, projections to the rostroventrolateral medulla activated the sympathetic nervous system, and epinephrine is released by the adrenal cortex and norepinephrine at postsynaptic sympathetic nervous system neurons. The efferent arc configuration is through the dorsal motor nucleus, and this action results in the release of acetylcholine at vagal postsynaptic neurons, inhibiting immune cells through the nicotinic acetylcholine A7 alpha receptors. What's important is the fact that we can control the functioning of both reflexes through the assessment of the heart rate variability. And our group here has good experience in this neurophysiologic technology. In this slide, it is shown how the CNS somatotopically is organized. The specific neural networks regulate or coordinate particular actions in the periphery. Advances in neuroimaging and neuroscience have made it possible to study this neural organization in humans. Knowledge about the cholinergic anti-inflammatory pathway as a specific regulator of cytokine responses make it possible to consider that there is somatotopic organization to central nervous system regulation and coordination of the behavior of the immune system. This slide is a result of localization of very new and interesting ideas related with the controls of the inflammatory and immune responses of the brain. 3 important conclusions can be shared. The discovery that cholinergic neurons inhibit acute inflammation has qualitatively expanded our understanding of how the nervous system modulates immune responses. The nervous system reflexively regulates the inflammatory response in real time, just as it controls heart rate and other vital functions. Now exists the opportunity to apply this insight to the treatment of inflammation through selective and reversible hardwired neural systems. Why do we believe it is important to include the study of the integrity of the autonomic nervous system in children with autism? First, because there is incontrovertible evidences obtained from autopsies and imaging sources that show lesions in the brain areas closely associated with the function of the ANS. This includes the prefrontal cortex, the amygdala, the anterior half of the cingulate cortex, areas in the insula, nuclei of the cerebellum, corpus callosum, and glial cells. Second, because the inflammatory factor is present in the brains of subjects with autism, as is the case in patients with ischemic or hemorrhagic strokes, traumatic cranial lesions, and several chronic diseases of the brain, as is the case in dementia, Parkinson's, and hereditary detoxifications. Third, because the immunological status in the autism spectrum disorder subjects has been found to be effective, damaging neurons and glial cells in the brain. Fourth, because the scanty but very well carried out assessments of the autonomic nervous system using different indices of the heart rate variability have shown that in these subjects is characteristic the presence of a significant reduction of vagal influences associated with the increasing activity of the sympathetics. These results are in agreement with the findings in many neurological diseases and demonstrate that in subjects with autism, the control of the functioning of the ANS can be used not only to assess the presence of an autonomic dysfunction, but more important, can be an objective and quantitative marker to assess the effects of many therapeutic procedures.
Thank you very much.
This is actually really neat. I don't know if you're familiar with this paper. If you're not, this is from Tracy from Nature 2009. And when we discuss how the brain, top-down, controls the immune system, the autonomic nervous system, the digestive system, like I said, all the things that we discussed yesterday about all the breakdown, all the issues, all the symptoms that you can get, how the brain and how the nervous system can actually cause that. One of the things they talk about in this paper, which is really fascinating, is that when you sever the afferent fibers from the gut on the vagus nerve, the individuals no longer get a fever when in the presence of an infectious agent. What we do know is that one of the things that's been baffling in the world of autism is there's many documented cases of autism showing almost complete changes in their symptoms with a fever. Meaning that when they're getting the fever, they're showing an increased, dramatic increase in vagal parasympathetic activation. And that these loops are responsible for that. We know that when we look at the brain, we look at the neocortex, we look at the prefrontal cortex, we've been talking about this for a long time as far as the descending control into the nucleus tractus solitarius from the brain and the neocortex. And this is the link, and this is really a fascinating link because now what we're looking at in Cuba is we're starting to measure this. And we're going to start to look at the role of the brain and functional neurology as far as how it regulates the autonomic nervous system, which could explain many things as far as the immune dysregulation, gut dysregulation, detoxification problems. And so looking at understanding not just the immune gut brain component, but the brain immune gut component. And so this is really fascinating stuff, and it's going to be exciting that we're going to add this to what we do. and when we look at therapeutic interventions and how we can alter this. So this was really a brilliant thing. Does anybody have any questions or anything they want to throw up? What we can do is they're both going to be part of the panel discussion. So we can, make that available for later. Okay? Yes. Okay. So let me get back to Machado.